Okay, let's explain this problem. So here in this problem, I'm given an array size n. Let's take any array. 1, 2, 3. And a non-empty subsequence of an array. So a subsequence of an array is a sequence such that I can get it from taking the array and deleting some elements from it. Okay, so if I have this array, one subsequence of it could be something like this, for example. Okay, I can delete any element from it, and I can actually take the array itself, and it is a subsequence of the array. Okay, so a subsequence of size 1 could be any one element. Subsequence of size 2 could be any two elements, so 1, 3, 2, 6, 3, 7, 1, 7, and so on. Okay, so in subsequence I can get the array and delete any elements from it, and this is a subsequence. Okay, also this is a subsequence of size 3. This is a subsequence of size 2. Okay, this is the definition of subsequence. So the problem says that the value of a subsequence, let's take 137. To calculate the problem says that to calculate the value of this subsequence, I'll get the binary representation of these elements. So these are 3 elements. Let's take their binary representation. So here 1, 1, 1. Okay. Here 1, 1, 1. Okay. So this is the binary representation for 1. This is for 3. This is for 7. Okay. So the value of this subsequence is summation of I of 2 power I such that the ith bit is set in at least the size of this subsequence minus 2. What does this mean? So the size of it is 3. So I should add the value of 2 power the ith bit if and only if the ith bit is set in at least one element, because 3 minus 1 is 2. So here 3 minus 1, 3 minus 2 actually is 1. So at least I should have at least one element in this subsequence such that the ith bit is set in it. So if I take the first bit, so the first bit is set in the 3 elements, right? So I should add it to the value. So the value equals 2 power 0 corresponds to the first element, to the ith bit. And for the second bit, it actually it is set in 2 elements, and 2 is greater than 1, so it should be okay. So 2 power 1. And for the third bit, it is set in only one element, and 1 is okay because at least one element should be set. So I'll add 2 power 2. Let's take let's add another element. Like 0, 1, 0. Okay. So here 4 minus 2 will be equals to 2. So the value should be different now. So now I want at least for every ith bit, at least 2 elements from this subsequence have the ith bit set. Okay. So for the first element, it is set in 3 elements. For the first bit, it is set in 3 elements. So I'll add the first 2 power 0. And for the second element, for the second bit, it is set in 3 elements. So this should be okay. And for the third bit, it is set in only one element, and 1 is more than 2. So I shouldn't add 2 power 2. Okay. So this is the value for this subsequence of size 4. Okay. So this is 2. Did you get the explanation for the problem? Did you get what the problem wants? And actually the problem wants us to maximum value we can get. Yes, so the problem wants us to choose any subsequence of this array such that we can get the maximum value possible. Okay, did you all understand this problem now? Because the statement is quite tricky. Okay, I think everyone's okay. Any ideas how to solve this?
Excuse me, can you just explain it again, please?
Okay. Um, so now, so do you understand what's meant by any subsequence, right?
Yes, I got that.
Okay. So now we want to choose any subsequence from this array and get its size, okay? And get the binary representation for each element in this subsequence. So if I choose 1, 3, 7, 2, and so 2 should be like this, okay? So 1, 2, 3, 7. I'll get the binary representation for each element, and then the problem says that the value for this subsequence should be equals to, I'll copy and paste this. So the value from representation. Okay. Okay, this is the formal explanation for how to calculate the value. Let's read it and then try to define it. So the value of a non-empty subsequence of k elements. So the size of this is k. K equals to 4 of k elements of A is defined as summation of 2 power I over all integers I greater than 0 or equal 0, such that at least, let's forget about this one now. Okay. So at least k minus 2 elements of the subsequence have the ith bit set in their binary representation. So I want to calculate the value of this subsequence. I want to add the summation of 2 power I. So 2 power I plus 2 power, so all 2 power i's, okay. So summation. So it will be the summation of 2 power I such that I is set in at least k minus 2 elements in this subsequence. That's it, okay. So here k equals to 4 and k minus 2 equals to 2, okay. So now I'll get this 2 and I want at least 2 elements. So to add the value of 2 power I to the value of this subsequence, I want to make sure that at least 2 elements are set in the binary. At least 2 elements are set in the binary representation of 2 elements of I. Okay, so for I equals to 2, I have 3 elements have the second bit set, right? So here the second bit is set in 3 elements, and for the first bit it is set in 3 elements. And if I have another element here, let's uh, let's delete this at this. So here I have the first bit is set in 2 elements, exactly 2 elements. The second bit is set in exactly 2 elements, and also the third bit is set in exactly 2 elements. Okay, so here for all bits I'll add 2 power I for all bits. Okay, so the value will be equals to 2 power 0. So 0 corresponds to the first bit, okay, not 1, plus 2 power 1 plus 2 power 2. So that's the value, okay. But if this equals to 0, then I cannot add 2 power 2 because the third bit is set in only one element. Did you get it now?
Yeah,
If you have
thank you.
1 point you didn't get it, just point it, okay?
Okay, yeah, thanks.
Okay. Okay, let's talk through the solution now, since no one have got a clue for it. Let's leave this. Okay. So to think for the solution of this problem, let's not go to complex solutions first. Let's think simple, and we'll find that simple works quite well. So good solutions are the simplest ones, not the complex ones. So we'll try to construct any subsequence and see what properties does it have, and see how to calculate this value. Okay, so let's take this. Let's take a generic subsequence A. Okay, so I have now subsequence A, and I want to make sure, and okay, I have here n, and I choose a subsequence A. So let's go to the value and see what properties the value of A have. So the value of A for each ith bit, if 2 power I is added in the value, so if 2 power I is in the value, then I'm sure that the ith bit is in at least A minus 2 elements, right? Actually is set. So if I added 2 power I, so for any I in the value, so this is by definition, but let's go from the beginning here. So if 2 power I is added in the value, then I'm sure that the ith bit is in at least A minus 2 elements, right? So now let's think from let's think from small a, then take it bigger. So what would be the value for A equals to 1? Should get it yourself now. So the value for A equals to 1. So if I'm just considering subsequences of size 1, then the value, so the maximum value should be the maximum element, right? So if n equals to 1, actually, then I can only choose one element. But if n is greater than 1, and if I should choose only subsequences of size 1, then the answer should be maximum element. Okay, so let's go for A equals to 2. What should be the value for A equals to 2? So here I said now forget about max 1 k minus 2. That means that if size of k is greater than 3, greater than or equals to 3, that means that I want to make sure that at least k minus 2 elements have their ith bit set. But if A is 1 or 2, then I want to make sure that only one element have the ith bit set. Okay, so 1 is, of course, I want to make that every I is set in this element. Okay, and for 2, if 2 power I is added in the value, then I want to make sure that at least one element in A have the ith bit. Okay, and of course for 3 and bigger, I want to make sure for at least k minus 2 elements. Okay, so for 2, so do you know what OR operation does? So A or B will be equals to summation of 2 power of all the set binary numbers in A and B. Okay, so the value for this will be equals to 1 1 1 1. Okay, so OR takes if at least one bit is set, then the OR operation takes this bit. Okay, so if I have, doesn't matter. Okay, so OR takes 1, gives 1 if 1 is set in at least one element. So that's it. So the value for A equals 2 will be maximum over all ORs. So what does that mean? For A equals 2, I'll make a loop. Just make int x for r for int y for r. So the answer for a equals 2 will just be the maximum between x or y over all pairs. That's it. Okay. So answer equals maximum answer x or y. Okay. So for a equals 2, I take the maximum over all ors, and this will be the value for a equals 2. So let's think greater now. For a equals to 3. So for a equals to 3, I want to make sure that at least 3 minus 2, which is at least one element, so the same for 2, I want to make sure that at least one element have the ith element set in the binary representation. Okay. If I thought about 3 and all the bigger elements, I'll actually come to an observation that I don't want to check for a greater than 3. Why? It's because if I have any subsequence of size k, and I want to and if value have 2 power I, then I want to check that I is in at least k minus 2 elements, right? So if I took any 3 elements from these k minus 2 elements, so I took a1, a2, a3. So now I know that I is in at least k minus 2 elements, right? So if I took 3 elements from these k elements, so if I took 3 elements from this subsequence from A, then I'm sure that I should be in at least one of them, right? Did you get this part? So now I'm sure that I is in at least k minus 2 elements, right? So if k equals to 5, let's take an example. So here A, I have some A, and the size of A is 5. That means that k equals to 5. So now I know that I is in at least k minus 2, which is 3 elements, right? So I is at least in 3 elements from the 5 elements. So if I took any 3 elements, let's say A1, A2, A3. If I take any 3 elements from these 5 elements, and I know that the ith bit is in at least 3 elements, then I'm sure that the ith bit in at least one of these elements, because it cannot I cannot say that uh, it is not possible that I is not in any of these elements, because if I took 3 elements, then the left elements are 2 elements. So I have another a4, a5. These are the left elements that I didn't take, and I know that I is in at least 3 of these elements. So it might be these 2 and this one and these 2, and this one and these 2. Okay, it might be anything, but at least three elements of these 5 elements should have the ith bit set in it. So actually, if I take for any k, and I know that I is in at least k minus 2 elements, then if I take 3 elements, then for sure the ith bit is set in at least one element. So this is called pigeonhole principle. Okay, I'll give to you the link in Wikipedia to read about it. Okay, pigeonhole. Okay, but briefly, what pigeonhole principle states that if I have n elements, and I have n plus 1 poles, so I have n boxes, okay, and I have n plus 1 balls, and each ball is numbered. So each ball is numbered, has a number on it from 1 to n. Okay, so each ball could be from 1 to n. So each ball is either 1, 2, 3, 4, 5, 6 until n. Okay. So due to pigeonhole principle, and it's obvious now that if I want to put these boxes in these balls in n boxes such that no box is empty, so now I'll be sure that at least one box will have duplicate number. Okay, so let's make it simple in terms of numbers. If I have n boxes, I have n plus 1 integers, and they belong to the interval from 1 to n. So now I have n slots, and I have n plus 1 integers, and each integer belongs to from 1 to n. So the interval from 1 to n. So I want to put each integer in one slot such that there is no slot is empty. So for example, if n is equals to 4 and I have n plus 1 integers, let's say 1, 2, 3, 4, 2, because I cannot put 5 because I'm allowed to put only from 1 to n. So now, due to pigeonhole principle, and it should be obvious now that at least there should be one duplicate in this array, right? Because I have n slots and I'm putting n plus 1 integers. So there should be at least one duplicate. So here, 2 and 2 is a duplicate. So it is not possible to not have any duplicate here. But if I have only n integers, then I'm not sure that there should be a duplicate. Okay? Did you get what pigeonhole principle says? Did you get the idea of it?
Yes.
Okay.
Yes.
Okay, so since we know this, so for this problem, it should be obvious now that if I'm choosing, if I know that for at least k minus 2 elements, the ith bit is set, then for sure at least one element from the 3 elements I choose from these k minus 2 elements should be set, should have the ith bit set. So actually this problem boils down to just calculating for a equals to 1 and a equals to 2 and a equals to 3. That's it. Okay, that's it. And actually I don't have to get a equals to 2, and I don't have to get also a equals to 1. Why? Because I'll have to get a equals to 1 only if n equals to 1. Okay, and a equals to 2 only if n equals to 2. Because for the OR operation, the more I add, the more it is better, right? So if I have an array of size n and n is greater than 2, so why search for only 2 elements, but search for 3 elements? Because the more I add to a, the more it is better. Because the OR only adds, it doesn't remove anything. So actually, for n equals to 1, I'll search for one element. For n equals to 2, I'll search for subsequences of size 2, which is the only pair, and the only pair. That's it. And for n greater than 2, I'll search for all pairs greater than 3. That's it. Okay? So it will be something like this. So that's it. That's the answer for this problem. Okay. Do you have any question about this proof, and is there anything you didn't understand? Make sure you understood this proof to the problem. Okay, I think everything's clear now. Let's call it. And this is a good hint, since n is up to 500, then the maximum number of operations I can do is n power 3. Okay, so this is a good hint to the problem. And the answer, the complexity, should be exactly n power 3. And a is very big, so that's it. So to make things faster, I'll not make for for int x and for int y and for int z, because for this way I'll pass through tuples multiple times. So I'll make it for int I equals to 0, I smaller than n, I plus plus. And I'll start from I plus 1 just to make it faster and to not pass through multiple pair through the same pair multiple times. Okay, equals I. So I'll start from j equals to I, not I plus 1. Why? Because I want to, if n equals to 1, then I want to take I with me. If n equals to 1, then I want to calculate I with itself. Okay, so and also I'll start k from j k plus plus, and here I'll have answer. So be careful that everything should be long, and the answer should be long. Okay, that's it. Let's try. Okay. Okay. Let's give you the link to the solution. Here the link in the chat. Let's go to the next problem. I sent the link. Take your time, read it for 3 minutes. And if you have any idea, speak.